Hello, my name is Christiana. I'm 25 years old and I'm a master's student at Lund University in Sweden. In this video, I'm going to talk about my project titled Dissolution Kinetic Study of Limonene in Supercritical Carbon Dioxide by in situ Raman Spectroscopy. What makes this project interesting? Solvents are present everywhere, from the coffee you prepare hot water every morning to the headache pill you take to be dissolved in your stomach. Then, it is important to know how much and how fast can you dissolve. In my case, the solvent is carbon dioxide at higher pressure and temperature, as a supercritical fluid. It is considered a green solvent, environmentally friendly because it is non-flammable, non-toxic, cheap, and naturally occurring, better than organic solvents. Because such dissolution kinetic studies are limited in the literature, we decide to explore more deeply this subject. Raman spectroscopy is a technique where the molecule interacts with the incident radiation provided by a laser. This results in a weak inelastic scattered light caused by the vibrational modes of the molecule shifting the laser frequency. Then, the Raman spectrum is like a fingerprint of your compound. It is important to say that the laser power we use here is much higher than the usual lasers, like the ones you use to play with your cat, for example. And this is the Raman setup that I used. We have built, so it has specifications that you cannot find in the market. And here you can see it's divided in an optical system and a pressurized system. In the pressurized system, you have the high-pressure view cell, where you load with your sample and a stir barrel. After that, you set up the temperature with the heating tape. The injection of CO2 is controlled by the pump, and that will lead to an increase of pressure inside the view cell. In the optical system, there is a laser source, and this laser will be reflected in the mirrors until it reaches the sample. Then, the light scattered back goes to the detector, and after the signal is processed, a spectrum is shown in the computer. In my experiments, I work with limonene, which is an essential oil highly soluble in supercritical CO2. After the setup was mounted with this stable pressure and temperature, the first spectrum was acquired and the acquisition was repeated at short time intervals. What I observed was the height of my peak increasing with time, which means that more of my compound is being dissolved in the solvent. In the end, I could build kinetic curves of the intensity of my peak against time. Limonene can take from a few minutes to a few hours to be completely dissolved in the CO2. The lower the pressure and temperature, the faster was the dissolution rate. Not stirring the solution affects the dissolution mechanism for some regions of pressure and temperature. So thank you for listening and I hope you like my project. Bye!